Okay, welcome back. What we're going to do now is we're going to talk about the elastics and inelastic and plastic flow stuff of the main material over here. Okay, so let me do something real quick. Let me open up the emit grid node. I want to make sure that I'm set to emit once at frame, and let me just hit play. See what we got. Basically, got a clump of particles that falls down, kind of splashes at the bottom of the bowl, and you get pretty much what you would expect. So with Lagoa, you can do elastic materials, and elastic materials are materials that behave like rubber or jello or something like that. Basically, it's a material that is soft. It can change shape when it bounces around and is hit by rigid objects, by colliders and things like that. But a high elasticity value tends to make one of these objects want to return back to its original shape. So if you were to take, say, some jello in a plate, and you take a spoon and you kind of push down softly on top of the jello and then lift the spoon up, you notice the jello compresses down as the spoon pushes it down, but then when the spoon comes back up, the jello kind of just bounces back to its original shape. Unless, of course, you push too hard and you crush the jello, and then you'll change its shape permanently. That's a whole different thing. So let's have a look at how to use these settings. Now, very important, I'm going to open up the multiphysics node. Just as I've talked about before, I'll reiterate. You want to make sure that under the optimization debug section of the multiphysics node that you turn on or off different items that you're going to be using or not using. So turn off stuff you're not using so that the simulation goes by faster, and turn on stuff that you are using, or else you won't simulate what you're trying to simulate. So right now I don't want to solve pressure. What I want to solve is let's play around with the inelastic settings for the moment. And inelastic settings are pretty simple. Basically, inelastic is the opposite of elastic. So if elastic bends and molds and changes shape and stuff, inelastic is not going to want to behave like jello. It's not going to want to return back to its original shape when it gets deformed and stuff like that. It's going to be very rigid. So this would be good. Inelastic is good to use for things like dirt or sand, just something that's more rigid like that, where you have these individual molecules that really don't want to clump up together if they're dry, if they're not wet, that type of item. So over here, I'm going to take off pressure. I'm going to take off elastics, viscosity, plastic flow, and custom elastic range, because I'm not calculating that stuff. Let me hit play real quick. And you notice that this is going to impact, and the particles are going to fall back on each other just because of gravity. But this object is not going to behave like jello. It's very rigid. Once it impacts, it kind of shatters. So if you're trying to go for something rigid like that, then inelastic is the way to go. Let me actually turn that off right now, and let me switch over to elastic, which are more interesting settings in my opinion. Let me turn off solve elastic. I'm going to come over here and turn off inelastics. I'm going to turn on elastics back on. And there's a lot of other settings over here you could turn on or off and things like that. I'm going to leave it alone for the moment. Let's play this again. It's going to drop down, and it's going to kind of bounce around in there. Let me zoom in here. You notice as I get close, you can see these little yellow lines that interconnect the different particles. Okay? These are your elastic links. It's basically a visual thing to help you, the 3D artist, visualize the elastic links. You could turn that off by coming down here to debug and turning display structure off. It's on by default, but you might want to have it on as it helps you visualize the little elastic links between the different particles. Okay? So let me zoom out a little bit here. Okay, so the particles pretty much fall down, and they kind of bounce on this object. See that? And here's another thing that's really important. I've noticed that my simulation is actually going pretty slow, slower than normal. Now, I've optimized this by turning off stuff I don't need in the multiphysics node, but why is it going so slow? Okay, one thing that really impacts performance is your collision object, because that's what's interacting with the simulation. So if I look at the cereal bowl, you notice that I made it a little bit too high res. I may have gone a little bit overboard with that. Okay, so when the object is really high res, the more resolution it has, the more complex the simulation, and the longer it's going to take. If I go to selection over here, you'll see I've got also a bunch of modeling history. So what I'm going to do is I'm going to freeze modeling. It's going to leave the ice tree alone because it's underneath the animation construction stack. So I'm going to take the bowl here. I'm going to go to my model menu set. I'm going to go to Modify Polymesh. I'm going to go to Polygon Reduction. I'm going to reduce the polygons on this thing. The original was about 4,000 triangles. So I'm going to drop it. I think about here looks pretty good, 70% ratio. So it went down from about 4,000 to about 1,300 triangles, which is pretty good. And I'll just leave that in my construction stack so I could always go back to it if I need to. The bowl looks a little bit low res, but it still serves its purpose. If I play this again. So let me take the elasticity here. And a high elasticity is going to make a very bouncy kind of object that kind of pops back to its shape after it impacts something. So let me drop that elasticity down. And elasticity works pretty good with plastic flow. Okay? But I'll show you that in a bit. So let's play this back. And it's going to slam down at the bottom of the bowl. And you notice that it doesn't pop back up to its original shape. It kind of stays compressed. And that's because we have a low elasticity. So even though this is kind of a rubbery, jello-like object, it's still not very elastic. So when it changes shape, it's going to stay changed. It's going to deform almost like silly putty or clay or something like that. Maybe like you think of it kind of like wet clay or something like that. Okay. Now the breaking point is a pretty interesting parameter because this allows the elastic object to break apart. So let's actually lower this and let's see if we can get this thing to break apart. And it almost broke apart. You can see the particles got juggled up right there, and this thing's a mess. Looks like something that got smashed by a hammer or something like that. The stretch and the shear resistance as well as the damping are all going to be parameters that work to have this thing resist stretching, shearing, and the damping parameter. If you have this pretty high, it'll help to try to make the object keep its shape or dampen the impact of the particles of the collision object, whatever the collision object. In this case, it's this bowl. So let me do something here. Let me increase the breaking point again and leave the elasticity at 1. That's going to make the object kind of bounce around. So it keeps its shape and kind of bounces around like an inflated ball or something like that. Alright. Now I'm going to play around with the plastic flow parameters. Now, to use plastic flow, you have to make sure you turn on plastic flow in the multiphysics node. Very important. Okay. So once that's turned on, we can start to introduce some of this plastic flow. And what the plastic's going to do, it's going to try to make the object get dented and bent out of shape. So think of a soda can. When you take a soda can and you kind of crush it with your hand, it gets crushed and then it kind of keeps that shape. It doesn't bounce back to its original shape like rubber or jello. Okay, so that's what the plastic flow parameters do. So I encourage you to play with these parameters, adjust them to your liking, and try to get something that looks the way that you want it to look. So there's a lot of tweaking involved with this. So let me increase the compression. Let me lower the plastic yield a little bit. Play this again. So you notice that once the particle cloud gets smashed to the collider object, it loses its shape, even though I have elasticity turned up pretty high. Okay, so I encourage you to play around with those parameters. Now you kind of get an idea of what they do. There's so many potential possibilities as to how to use these parameters to mimic and create different materials, from a bouncy type ball to a piece of foam, whatever you can think of, or whatever your project entails. So go ahead and play with the parameters and get used to them, understand how they work. I'm going to go ahead and close this stuff out. I'm going to end this video here, and in the next one we're going to talk about colliders in Lagoa.